Alright, this is your last construction involving triangles and the point of concurrency. We've got one more that's kind of neat that I want to show you. So get that scalene triangle one more time. We'll create it. Alright, this time we're going to create the altitudes of the triangle. You probably know the altitudes better as if I were to say the height of a triangle. You know, like area equals 1/2 base times height. So the height of a triangle goes from the vertex perpendicular to the opposite side. Well, another name for the height of a triangle is the altitude. So once we get into upper level geometry, we call that the altitude instead of the height. So what I want you to do is I want you to go over here and find your perpendicular line tool. This one that it's not the perpendicular bisector tool. You want your perpendicular line tool. And when we hover over that, it says select a point and the perpendicular line. So we're going to select the point as a vertex. Then we're going to select the line opposite that is perpendicular to the line. So there creates the height. The height would actually go from the vertex right there to that point on the triangle, but the whole line itself is called an altitude. We need to do that with each of the sides. So I'm going to keep that perpendicular line tool and I'm going to create through that point a line perpendicular to this line. Through this point a line perpendicular to that line. And there are the altitudes of the triangle. And yet again, they are all concurrent at a point called the fill in the blank. The altitudes are all concurrent at a point called the what? When you find that out, let's go ahead and get our text tool and we will name that point. And we're going to put that right on our picture. So let's do our intersection tool. Intersect. There I already have the intersection tool. And we're going to intersect two of those altitudes so that it creates that point of concurrency. Now, really, that's all you need to do with that. One thing that I do want to mention that's kind of neat about this triangle, if you get your selection tool, your move tool, and let's just check out what happens to that point of concurrency as we move this vertex around. Notice if I create a right triangle. Notice what happens to that point of concurrency. Those altitudes all will meet right there at the right angle. And that's really kind of interesting and fairly useful in some different areas of geometry. That point that comes together right there, if it's a right triangle, it comes together, it just so happens to hit right there at that vertex. If you try an obtuse triangle, notice my obtuse angle there, the altitude, the point of concurrency seems to fall outside of the triangle. But if you create an acute triangle, then the point of concurrency of the altitudes falls inside or the interior of the triangle. So those are the only kind of really interesting things of the orthocenter that we need to be concerned with. As far as that goes, there is one more construction that I would like you to investigate on your own. We've done 4 constructions together. What I would like for you to do, if you're interested, for an extra 10 bonus points, is I want you to look up an Euler line. Euler, that's spelled E-U-L-E-R. Euler line. And I want you to construct on GeoGebra, for me, the Euler line. And then I want you to use this text tool, and I want you to explain to me how that what that line consists of. What points are on that Euler line. So if you want to do that and add a 5th construction to your Google Doc and turn that, before you turn that into me, then I will add an extra 10 bonus points to your score. That will be just in addition to the 4 constructions that you already have. So before I forget, let's go ahead and export this picture and make sure you label that as your altitudes. That's your altitudes of a triangle. Save that wherever you want it. If you're saving those on your desktop or wherever, just save those, and that way you can insert those into your Google Doc before you share it with me. So anyway, that's the altitudes of a triangle, and that concludes our 4 constructions, unless you want to do that extra